Earth's historical wounds, climate, and geological reconstruction after the Yellowstone supervolcano eruption. 640,000 years ago, Earth experienced one of the deepest wounds ever carved in geological history. In the heart of North America, pressure that had been building for hundreds of thousands of years finally reached a tipping point. The enormous magma chamber beneath Yellowstone, a hot reservoir hundreds of kilometers wide, began to destabilize. Earthquake waves shook the ancient ground, fissures opened in the surface, and columns of magma rose toward the Earth's crust. Until finally, in a brief but historic moment, Earth unleashed one of the greatest supervolcano eruptions of its time. When the world split apart, the eruption begins. The Yellowstone eruption wasn't just powerful, it was colossal. In its opening seconds, a phreatomagmatic explosion ripped through the surface, spewing rock, gas, and ash into the atmosphere with energy, thousands of times greater than any eruption ever experienced by modern humans. The eruption column pierced the stratosphere, forming a volcanic mushroom cloud that extended 40 to 50 kilometers into the air, carrying billions of tons of particles. The ground beneath Yellowstone collapsed, creating a giant caldera 70 kilometers across. The eruption lasted for days, even weeks, destroying vegetation, incinerating ancient forests, and wiping out all life within a radius of hundreds of kilometers. The ejected hot rock fell back as ignimbrite superheated pyroclastic flows that traveled at speeds exceeding through 300 kilometers per hour, engulfing valleys and mountains. For thousands of years to come, these rock layers bore silent witness to an almost unimaginable ancient catastrophe. Blackened skies, the beginning of volcanic winter. While North America was blanketed in thick ash, Earth's atmosphere underwent a drastic transformation. Sulfuric gases from the eruption reacted with water vapor, forming sulfuric acid droplets that created an aerosol curtain in the stratosphere. This curtain reflected sunlight back into space, triggering a decrease in solar radiation reaching the surface. In modern paleoclimate reconstructions, scientists have found evidence that global temperatures dropped by a -5 degrees Celsius. Cooling lasted for decades to centuries. Ash clouds blocked the sun for months. Global precipitation changed drastically. Northern latitude wind systems underwent a major shift. Earth entered a volcanic winter that accelerated the ongoing glaciation period. Glaciers grew, ice thickened, and tundra ecosystems strained to survive. Ecosystems struggle in the shadow of ash. Yellowstone ash, carried by the jet stream, spread more than 1,500 kilometers eastward. The American Midwest was covered with several centimeters of ash, enough to cover ancient grasslands and eliminate some of the habitats of large herbivores. In the West, the landscape was completely transformed. Ancient coniferous forests burned or were buried. New lakes formed from lava dams. Ancient rivers changed their courses. Hundreds of plant species became locally extinct. Remaining Pleistocene fauna, such as early mammoths, ancient horses, large bison, and prehistoric bears, faced even harsher conditions. Their populations dwindled in the most affected areas. But life always finds a way. Adaptable species began to thrive in new areas, paving evolutionary paths that would shape North American ecosystems for the next tens of thousands of years. Impact on global life and evolution. Human ancestors like Homo erectus lived in Africa and Eurasia at the time, and were therefore not directly impacted by the eruption. However, global cooling affected animal migration patterns, the spread of grasslands, the variety of food sources. These changes contributed to evolutionary dynamics that shaped the developmental trajectories of many of the world's major species. Some studies suggest that Yellowstone ash falling in the North Atlantic even altered local ocean chemistry, affecting plankton patterns and the marine food chain. Earth scars still visible today. The eruption's 640,000 years ago left a geological legacy that we can still see. Yellowstone caldera, the 70 km wide basin. Visible today is the direct trace of the collapse of the surface after the magma chamber emptied. Lava Creek Tuff, a layer of pyroclastic rock, hundreds of meters thick, a hallmark of a supervolcano eruption. Modern geothermal systems. Residual heat beneath the caldera gave birth to Old Faithful, Steamboat, Geyser, Mammoth Hot Springs, Norris Geyser Basin. The phenomena that have become iconic in Yellowstone are the result of an ancient wound that still pulses. Transcontinental ash distribution. Across archaeological sites and sedimentary layers, Yellowstone ash serves as an important time marker that allows scientists to measure ancient climate change. Legacy and commemoration. Yellowstone eruption, years ago, is a reminder that Earth's geology is a living force. When a supervolcano awakens, the scale of its impact spans the entire planet. Today, Yellowstone remains active. The magma chambers still exist. Heat still flows. Geysers still unleash their fury on a smaller scale. But past eruptions teach one thing: Earth is a living archive of ancient wounds, and each scar tells the story of how the planet continues to shape itself and the life on it.